Alright, so this is section 1.2, which is all about quadratic equations. So a quadratic equation is any equation that can be written in the general form ax squared plus bx plus c equals 0. It doesn't necessarily have to be in that order, but it does have to be in that form. A, b, and c are all real numbers, so they're not imaginary, and a cannot be equal to 0. That means we do have to have an x squared if it's going to be a quadratic. Another name for a quadratic equation is a second-degree polynomial, okay? Which is another way of saying that. Now, one of the properties that we rely on in order to be able to solve quadratic equations is called the zero product principle. The zero product principle basically says that if you have two numbers, a times b, and that product equals 0, then you know either a had to be 0, b had to be 0, or they both had to be 0. Okay? Now we use this when we talk about quadratic equations because a lot of times we can rewrite quadratic equations as the product of two factors, and then we can say, oh, well, because those two factors equal 0, then one of those factors at least has to equal 0. And so we can actually kind of apply that. So here are our steps for applying this zero product principle to quadratics. The first step is rewrite the equation in the form ax squared plus bx plus c equals 0. So that way you have all the non-zero terms on one side and you have 0 on the other side. Step 2, factor completely. Factor your equation as much as possible. I trust you're okay with factoring because that's not something we teach in college algebra. It's a kind of a prerequisite skill that you need. Step 3, apply the zero product principle. Take your factors and set each of them equal to 0. Step 4, solve the equations that you got from step 3. And then step 5, check your solutions back in the original equation. Make sure that they do work. Okay? So let's look at an example of this. Example 1a, we're solving by factoring. We have 4x squared minus 2x equals 0. The first thing to do is make sure that all the non-zero terms are on one side and 0 is on the other side. And that's already that way. There is a 0 here and everything else is non-zero on that side. So we're already okay there. The second step is to factor. Now, because this is just a two-term equation, we can factor by looking for the greatest common factor. So what is in common between both of these? Well, in common number-wise, we can pull out a 2. And in common variable-wise, we can pull out an x. If we pull a 2 out of 4, that's going to leave 2 behind. And if we pull an x out of this x squared, that will leave behind an x. And we put a minus. If we pull a 2 out of 2, it leaves a 1 behind. Same thing with the x. Okay? Because 2x times 1 makes 2x. Okay? It does not leave behind a 0. It has to leave behind something. Okay? So there we are. It's factored. Now that it's factored, the next step is to set our factors equal to 0. So we'll say 2x equals 0 and 2x minus 1 equals 0. On this one, we can just divide both sides by 2. And so we get x equals 0 divided by 2 is 0. On this one, we would add 1 to both sides. And so we would get 2x equals 1. And we would divide both sides by 2. And so we'd say x equals 1/2. Now, before we box these answers in, we do want to check them in the original equation. So let's start with 0. I'm just going to plug it in here with my calculator. 4 times 0 squared minus 2 times 0. I do get 0, so that one does work. That one's okay. All right, now let's check the 1/2. 4 times 1/2 squared minus 2 times 1/2. Yep, I get 0. That one's okay too. So both of those answers are okay. So I can box them in. So box that one in, and box that one in. And so there we go. Alright, so let's look at our next one. We got 2x squared plus 7x equals 4. Again, first thing to do is get everything on one side so that it equals 0. So I need to move this 4 over with subtraction. So I have 2x squared plus 7x minus 4 equals 0. Then I want to factor that. So I have some parentheses, because this is a it's a trinomial, 3-term equation. In order to make a 2x squared at the front, I'm going to have a 2x getting multiplied by an x, because that's the only way I can get 2x squared. Now to get a 4 here at the end, I have 2 different possibilities. I could either do 1 times 4, or I could do 2 times 2. Looking at the middle number that's 7, 2 times 2 is not going to work. Only 1 times 4 will work. And the reason why is if I set up a 1 here and a 4 here, then this 2x would get multiplied by this 4 and would make an 8. And then this 1 would make times x would make a 1x. 8x and 1x can make 7x as long as the 8 is positive and the 1 is negative. So there it is. There's what it looks like factored. Set your factors equal to 0. On this one, we would add 1, and so we'd say 2x equals 1, divide by 2, we get x equals 1/2. On this one, we would subtract 4 on both sides, and so we would get x equals -4. And then we'll use our calculator to help us check it. So I'm going to start with 1/2. I'm going to plug it back into the original. 2 times 1/2 squared plus 7 times 1/2. Yep, it does give me the 4 that it's supposed to. So that one's okay. Then we'll try the -4. 2 times -4 squared plus 7 times -4. And that gives me 4 as well. So those were both good answers. So we can box them in. Alright, so there's those 2 answers. So that's factoring. Alright. We have another method that we're going to look at here. Scroll a little bit. So the next thing we're going to look at is square root property. This is just saying that if you have u squared equals d, then you can solve that equation by taking the square root, but you need to have a plus or minus on it. The reason why you have to have a plus or minus is, just as an example, if you take 2 and you square it, you get 4. If you take -2 and you square it, you also get 4. So how do I know when I take the square root of 4 whether I should write +2 or -2? I don't know. So I put a plus or minus to cover my bases on either side. Okay? So there are certain types of quadratic problems where we can solve with the square root property. If you have an equation that's in the form ax squared plus c equals 0, meaning all you have is a square and a constant, then you can solve this with the square root property. The first thing to do is move the c over so that you have ax squared equals c. The second step, divide by a so that you get x squared equals c over a. And then you use your square root property to get rid of the square. Once you do that, the last step is to check your solutions back in the original equation. So let's look at some examples of this. So example 2 asks us to solve using the square root property. So 2a, we have 3x squared minus 15 equals 0. So the first thing we would want to do is we would want to add 15 on both sides. So plus 15 and plus 15. So I have 3x squared equals 0 plus 15 is 15. And I would divide both sides by 3. And so I get x squared equals 15 divided by 3 is 5. And then to get rid of the square, we're going to take the square root. But remember that we have a plus or minus. So this is plus or minus the square root of 5. And so I'm going to check those answers, make sure that they work. So 3 parentheses square root of 5 squared minus 15 does equal 0. 3 parentheses negative square root of 5 squared minus 15 also equals 0. So they both work. The positive and the negative both work. So I'd come down here and I'll just box in my answer. And up. Alright. Letter B, we got 9x squared plus 25 equals 0. So the first thing we'd want to do is we would want to move the 25 over, so we're going to want to subtract 25. So I have 9x squared equals 0 minus 25 is negative 25. Then I would want to divide both sides by 9. So I end up with x squared equals negative 25 over 9. So then I would take my square root. So we'd have x equals plus or minus square root negative 25 over 9. Excuse me. Now, here's the thing. In section 1.3, we're going to talk about complex numbers and imaginary numbers. But one thing to know is that if you have a negative under a square root, it's really an imaginary number. So you can pull out an I here to represent that negative, and then just rewrite the positive number. So this I out front just represents the fact that there was a negative inside that square root. So it tells us it's imaginary. And then we can actually do this a little bit further. So we have I times, what's the square root of 25? Well, the square root of 25 is 5. What's the square root of 9? It's 3. So we really have plus or minus I times 5 over 3, which we can say is x equals plus or minus 5 over 3I. Now, this one you really can't check in the calculator because the calculator can't handle the imaginary numbers, but trust me, it does work. Alright, letter C. Letter C, we have x minus 2 squared equals 6. Well, they have already isolated it so that the square is by itself, and we've moved the constant over. So the next step is to get rid of the square by taking a square root. So we're going to have x minus 2 equals, when we take the square root, we put plus or minus, and then we have a square root of 6. Now, square root of 6, I can't simplify that, so I'm just going to have to leave it as it is. What that means is I actually have two different possibilities for answers. I have x minus 2 equals the square root of 6, and I have x minus 2 equals the negative square root of 6. So I have to solve both of those by adding 2 on each side. So over here I'll get x equals the square root of 6 plus 2. For this one, when I add 2 on both sides, I'll get x equals the negative square root of 6 plus 2. And then I need to check those answers, make sure that they actually work here. So if I go to my calculator, move this over a little bit, I have parentheses, square root of 6 plus 2 minus 2, close parentheses squared. Hey, that does equal 6. And if I check the other one, this is negative square root of 6 plus 2 minus 2, close parentheses squared. And hey, I get 6 as well. So either of those answers will work. They are both valid. Okay? So that's another method of solving these equations using the square root property when you just have a square and a constant. All right. Yet another method that we're going to look at is the method of completing the square. And this is probably the most complicated method for doing these things. It's just a little bit different. Okay. So with this method, what we're going to be looking at is how we can turn an equation that is not a perfect square trinomial, something that really factors easily, into something that is a perfect square trinomial and will factor really easily. So, if you have a binomial that's just x squared plus bx, then by adding the term b divided by 2 squared, which is the square of half of the coefficient of x, it will give you a perfect square trinomial. What that means is you'll end up with x squared plus b over x plus b over 2 squared, which will factor nicely into x plus b over 2, that whole thing squared. So whatever this b over 2 is right here, you'll get the same b over 2 right here, and it's just x plus that squared. So it'll factor really, really nicely. So this is a way to actually take an equation and turn it into something that's factorable. So the steps that we use for solving a quadratic equation by the method of completing the squares is we write our equation in the form ax squared plus bx equals c. So we move the constant over here to this side. And then divide, if necessary, to make a equal to 1. So if this a number is not 1, we just divide everything to make it become 1. Once we've done that, the next step is we complete the square, meaning we add this term, the b over 2 squared, to both sides of the equation. We have to add it to both sides, so that way we maintain the validity of the equation, that it's still equal. Step 3, factor the perfect square trinomial. By adding this to both sides, you will create this on your left-hand side, and it will factor into this every time. The other side of the equation you can just simplify. You'll be adding two constants together, and it'll just be a constant. Once you get to that point, step 4, you can use the square root property to get rid of this square on your factor, and then you can solve the equation. And then the last step, of course, is to check your solutions to make sure that they are valid. Alright, so let's look at an example here. This one's not actually asking us to solve, it's just asking us what do we need to put onto the end of it to make it into a perfect square trinomial. So how do we complete the square? Well, remember, again, you're going to add b divided by 2 squared. So in this one, our b is 8, so we'd have 8 divided by 2 getting squared. What is 8 divided by 2? That's 4. What is 4 squared? That's 16. So we need to add a 16 onto our equation. So our equation would be x squared plus 8x plus 16. Okay? And then it asks us to factor it. When we factor it, you know it's going to be a parentheses with a square. You know it's going to be an x there. Now, what goes in here is whatever was in this parentheses. So in this case, for us, in the parentheses was a positive 4. So we put a positive 4 right there, and that's what it would look like factored. Okay? So this is what we needed to add. We needed to add 16. Once we added 16, then it would factor just like this. All right, let's look at letter B. We got x squared minus 7x. So again, we want to figure out what we need to add to the end. So I'm going to take this b, which is negative 7 over 2. Oh, I'm going to take negative 7. Sorry, divide it by 2, and then square it. Now, I really can't simplify negative 7 over 2, unfortunately, but I can do the squaring. Negative 7 squared is 49, and 2 squared is 4. So this is what I need to add on to the end. I need to add 49 over 4 to the end of this, which means my equation would be x squared minus 7x plus 49 over 4. And then when we factor it, we're going to have an x, parentheses, squared. What goes next to this x is what was in the parentheses, so it was a negative 7 over 2. And so that's what it would look like factored. Okay. All right. Letter C, we got x squared plus 3/5 x. So we're going to be taking 3/5 and dividing it by 2, and then squaring it. Now, this is something you should have learned in an earlier class, but we have 3/5 divided by 2 over 1, because 2 is really just 2 over 1. When you divide by a fraction, you're really multiplying by the reciprocal. So this is really 3/5 times 1/2. You just flip this bottom one. And so when you do that, you end up with 3 times 1, which is 3, over 5 times 2, which is 10. So 3/5 divided by 2 ends up giving us 3/10. And then we're squaring that. So when we square it, 3 squared is 9, and then 10 squared is 100. So we need to add 9 over 100 to this equation to make it a perfect square trinomial. And so when we do, we would have x squared plus 3/5 x plus 9 over 100. And then for how it factors, there's going to be a parentheses with a square, there's going to be an x, and then what goes next to the x is what was in this parentheses, and that parentheses was a positive 3 over 10. And so that's how it would factor. And so there we go, we've created some perfect square trinomials by completing the square. So now, let's take that and apply it to some other problems. So example 4 here asks us to solve this problem by completing the square. The first thing we need to do is we need to move the constant over. So we're going to have x squared minus 6x, I'm going to leave a little bit of space, equals, when I move the 4 over, I'm going to have a negative 4. Now once I do this, what I'm going to do is I'm going to put plus blank on both sides. Now I'm doing it on both sides to maintain the equality, to make sure the equation still is equal. But why I have to put it here on the left side is so that I can create my perfect square trinomial. So let's see what needs to go in this blank so that we create our perfect square trinomial. So let's complete the square. Take your middle number, which is negative 6, divide it by 2, and then square it. What is negative 6 divided by 2? It's negative 3. What is negative 3 squared? It's 9. So what goes in both of these blanks is a 9. So plus 9, plus 9. Now, on the left-hand side, we have a perfect square trinomial, so it will factor. So I'll have parentheses squared. In this parentheses, I'll have an x. And next to this x, we will write down what was in the parentheses over here, which was a minus 3. Over on this side, negative 4 plus 9, that gives us 5. So now we have this equation. We've changed it into x minus 3 squared equals 5. To get rid of the square, we take a square root. So we'll have x minus 3 equals plus or minus the square root of 5. So that really means we have two different possibilities here. We have x minus 3 equals the positive square root of 5, and we have x minus 3 equals the negative square root of 5. For this one, we would add the 3 on each side, so we would end up with x equals the square root of 5 plus 3. On this one, we would add a 3 on each side, and so we would end up with x equals the negative square root of 5 plus 3. And then we could check our answers, make sure that we did it right. We'll just take them and plug them into the original here. So square root of 5 plus 3 getting squared minus 6 times the square root of 5 plus 3 plus 4. Hey, look, it does equal 0 like it's supposed to. And you could do the same thing with the other one. You would just add a negative on both of those, and it comes out as 0 as well. So it does work. Those are good answers. Okay. So there was example 4. Let's look at example 5. So example 5 asks us to solve this one by completing the square. So our first step is to move the constant over. So we'll have 9x squared minus 6x equals 4. But we have an additional part to this first step. In order to do completing the square, the coefficient in front of the x squared has to be a 1. Right now this is not a 1, so I actually need to divide everything by 9 in order to make this work. 9x squared divided by 9 is x squared minus 6x divided by 9. Those can simplify. They're both divisible by 3. So this becomes 2/3 x. And I'm going to put plus blank equals. 4 over 9 does not simplify, so I'm just going to leave it. But then I'm going to also put a plus blank there. And so now we're ready to complete our square. So we're going to take our middle number, which is negative 2/3, and we're going to divide it by 2, and then we're going to square it. Now remember, this is really negative 2/3 divided by 2 over 1, which really means we have negative 2/3 times 1/2. This 2 can cancel out with that 2, negative 2, and leave a negative 1 behind. So we have negative 1 times 1, which gives us negative 1, and then on bottom we still have a 3. So this is really negative 1/3 getting squared. And then if we actually square it, negative 1 squared is 1. 3 squared is 9, so it's 1 over 9. And that's going to go in both of these blanks. Okay. Once we've done that, the left side will now factor, because it's a perfect square trinomial, and I don't know what just happened there. Sorry about that. Oops, sorry again. It's acting up once more. So we have a parentheses squared equals. Now in this parentheses, because we're completing the square, we know there's going to be an x, and next to this x is whatever was in the parentheses. So we have a negative 1/3 in there. Then over here, 4/9 plus 1/9, those added together they make 5/9. Then to get rid of the square, we can do the square root. So we say x minus 1/3 equals plus or minus the square root of 5 over 9. Now to this point I want to just talk for a second. When we have the square root of 5 over 9, really what we have is the, sorry about that, the board went a little crazy again. What we really have is the square root of 5 getting divided by the square root of 9. Now, square root of 5, I don't really know, so I'm just going to have to leave it as square root of 5. But square root of 9, I know, right? Square root of 9 is 3. So really what this equation is saying is I have x minus 1/3 equals plus or minus the square root of 5 over 3. So I have two different possibilities. Okay, I have x minus 1/3 equals the positive square root of 5 over 3, or x minus 1/3 equals the negative square root of 5 over 3. In either case, we're going to add the 1/3 across, and so I'll have x equals the square root of 5 over 3 plus 1/3, and then over here, x equals the negative square root of 5 over 3 plus 1/3. Now, it is okay to leave those like that, okay? But you could, because they have the same denominator, you could combine them together. So like this could be x equals square root of 5 plus 1 all over 3. And this one could be x equals negative square root of 5 plus 1 all over 3. And that works because they have the same denominator. They're both over 3. So you don't necessarily have to write it this way, but you could. So there's our answers for that one, and trust me, they do work. They are okay. You can check them in the calculator if you don't trust me. All right, the last method we're going to look at for solving quadratic equations is the quadratic formula. So the solution of a quadratic equation in general form, ax squared plus bx plus c equals 0, is given by the formula x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Now, if you've never seen this, actually I don't think I can play sound on this, never mind. If you go to YouTube and you Google quadratic formula song, okay, if you search it there on YouTube, you'll find out that lots of people use the song Pop Goes the Weasel to help them remember the formula for quadratics. I learned that when I was in school a long, long time ago, and that still helps me remember it. So if you need to, a good way to remember, watch that on YouTube a couple times. It will get stuck in your head. But this is a formula that any quadratic that's written in the form ax squared plus bx plus c equals 0, you can find x by just plugging in the b, the a, and the c. Okay. So let's look at an example using that. Example 6 here asks us to solve using the quadratic formula. We have 2x squared minus 6x plus 1 equals 0. So we're going to fill in. We have x equals negative. What's my b? My b is the number here in front of the x, so I have a negative 6 there. And then my tablet's going to go wonky for just a second, apparently. Plus or minus, we have a square root. We have b squared, so our b is negative 6, and that's getting squared, minus 4 times our a is the first number, the number in front of the x squared, so it's a 2, times our c is the last number, which is the constant, which is a 1, and then all of that is over 2 times the a, and again the a is the number in front of the x squared, that's a 2 there. So if we look at this, negative 6 means we have positive 6, plus or minus, we're going to have a square root. Now, what I'd like to do is I'd like to figure out what this number is, and so I'm going to go to my calculator to help me figure it out. So I've got negative 6 getting squared minus 4 times 2 times 1. So that's a 28 inside there. On the bottom, 2 times 2 is 4. Now it's at this point that I want to talk about simplifying radicals, because we do need to simplify them. This radical here with the 28 could be simplified. Okay. How you check if you can simplify is you make a factor tree. So I'm going to start with 28. Okay. And I'm going to try to look for the smallest number I know of that goes into 28. Now because this is an even number, 2 will go into it, so it would be 2 and 14. What's the smallest number that goes into 14? Well, that's 2 again, so I have 2 and 7. What's the smallest factor that goes into 7? Well, 7 is the only factor that goes into 7. Okay? So this is what the factor tree looks like. Once you get there, you look for pairs. I have a pair of 2's, which means that I can take a 2, a single 2, out of this factor, out of this radical, and put it in front. So what I would have is 6 plus or minus 2 radical, square root. Now what's left inside the square root? This number here that wasn't part of the pair. So the 7 is still inside there. And that's still all over 4. Now, this can be simplified a little bit more because the numbers that are on top are both divisible by 2. They're both factors of 2. So I can actually factor a 2 out of the top, and that would leave a 3 behind from the 6. And then we have a plus or minus, and it would leave a square root of 7 behind from the 2 square root of 7. So basically I just pulled a 2 out of this, leaving a 3 behind, and I pulled a 2 out of this, leaving the square root of 7 behind. And then this 2 here can cancel out with the 4 down here and leave 2 behind. So what we have is 3 plus or minus the square root of 7 over 4. So that means we really have 2 possible solutions. I have 3 plus the square root of 7 divided by 4, and I have 3 minus the square root of 7 divided by 4. So those are my 2 solutions to this quadratic equation. Okay? Let's look at another one. Example 7 here, we have solve using the quadratic formula, 3x squared minus 2x plus 4 equals 0. So again, we're going to set up our quadratic formula. We'll say x equals negative b. My b here is negative 2. Plus or minus the square root. We're going to do our b squared, so negative 2 squared, minus 4 times the a, which is 3, times the c, which is 4, all over 2 times the a, which was 3. Now, a negative 2 means we have a positive 2. Plus or minus, we have a square root. I want to find out what's in that square root. I use my calculator. Negative 2 squared minus 4 times 3 times 4. We have a negative 44 inside there. So, yeah, pretty big. Negative 44. And then on the bottom, 2 times 3, that is, of course, 6. If I can actually write the number 6, which apparently I cannot. 6. Now you do want to simplify that radical, so we'll make another factor tree. So we have negative 44. Ignore the negative right now, just focus on the 44. So 2 would go into it, and it would leave 22 behind. 2 would also go into that and leave 11 behind. And then there's nothing that goes into 11. So my pair is just this pair of 2's. There'll be an 11 behind. Now, let's go back to that negative. That negative underneath that radical means this is going to be an imaginary. So we're going to have an I. So instead of that negative, we're going to write an I out front of the radical. So we'll have an I in front of the radical. We'll also have a 2 from this pair here that will be in front of the radical. So I'll have 2 plus or minus 2i square root, and then the number that was left inside the square root was an 11 over 6. So I have 2 plus or minus 2i square root of 11 over 6. Then I can simplify a little bit more because I can factor a 2 out of the top, and it'll leave behind 1 plus or minus I square root of 11, all of that over 6. The 2 can simplify with the 6 and leave 3 behind. Sorry about that again. 3. So what we really have is 1 plus or minus I square root of 11, all of that over 3. Which really means we have 2 answers. We have 1 plus I square root of 11 over 3. And we also have another answer, which is 1 minus I square root of 11 over 3. So these are our solutions to the quadratic equation. Now obviously we can't check those because they are imaginary, or we can't check them with a calculator, but they do work. All right. The last thing that we are going to look at in this set of notes is just an example of a problem, a real-world problem, that can be modeled by a quadratic equation. Okay. So example 8 here says, from each corner of a square piece of sheet metal, remove a square of 9 centimeters. I don't know where the rest of the word centimeters went, but it's supposed to say centimeters. Turn up the edges to form an open box. If the box is to hold 144 cubic centimeters, what should be the dimensions of the piece of sheet metal? So imagine you have a square. This is my bad representation of a square. Now, I don't know the dimensions of this square, so I'm just going to say it's x times x. But, sorry, recording box is up. Okay. So what we're doing is we're taking this square that we don't know, what the dimensions of it are, and we are cutting out a little corner, a little square in each corner. Okay. So we're just cutting those off. They're gone. Okay. So if you want to kind of imagine it, imagine like cut it off like that, that. Okay. So this is what our little shape looks like after we cut the corners off. Okay. And then what we're going to do is we're going to fold along these dotted lines right here. And when we fold along those dotted lines, these little sides, this little piece here, this little piece here, this little piece here, and this little piece here, will fold up and we'll make an open box, basically a box that does not have a top to it. So you can actually just look down inside of it. Okay? So what we're going to have is a kind of a three-dimensional box, and I'll try and draw it really quick. It'll look kind of like this. See if I can draw. I'm not an artist, so my drawing skills are not the best. It looks something like that. Now, we know how high this is because this height is actually based off this cutout, because when we fold this up, these are going to become the heights of the box. So this cutout we know was 9 centimeters. So we already know that this height right here is 9. What we don't know are the dimensions that are here and here, but we can kind of estimate. Originally, this side of the box was x long, but they cut out 9 here and 9 here. So now that side of the box is x minus 18, because I took off 9 and another 9. The same thing is also true on this dimension going this way. Okay. Originally we had x, but they took away 9 here and they took away 9 here. So now this dimension is also x minus 18. They are still the same. They are still squares. Okay. So they're still the same dimension, but they're x minus 18. So knowing that we have these three dimensions, we could write an equation for the volume of this box. The volume of any kind of rectangular prism is length times width times height. So for this problem, that would be x minus 18 times x minus 18 times the height of 9. And so if we kind of clean that up, x times x is x squared. Negative 18 times x is negative 18x. X times negative 18 is also negative 18x. Negative 18 times negative 18, I don't know what that is, but I'm going to find it really quickly. 18 squared is 324. And then that is getting multiplied by 9. I'm going to combine like terms, so x squared minus 36x plus 324. And then lastly, I'll distribute the 9 in. 9 times x squared is 9x squared. I don't know what 9 times 36 is, so I'll find that out here. That's 324, so minus 324x plus 324 times 9 is 2916. So there's my volume equation. This is the volume of the box, depending on how big x is. Now, they told us up here in the problem that the volume, V, has to be 144 cubic centimeters. So they're actually giving us this value, so we can plug it in here. 144 equals 9x squared minus 324x plus 2916. Now to solve this, I'm going to first off subtract that over, so that way I have a 0 on the left. So 0 equals 9x squared minus 324x, and then I need to figure out 2916 minus 144, which is 2772. And now, in order to simplify this, I think what I'm going to do is I'm going to divide everything by 9, because I think they're all divisible by 9, and that'll make my life a little easier. 0 divided by 9 is 0. 9x squared divided by 9 is x squared, minus, over here, 324 divided by 9, that's probably 36 if I remember correctly. Yeah, 36. So minus 36x plus, and then if I take my 2,772 and divide that by 9, I get 308. Okay. So now my equation looks a little nicer. 0 equals x squared minus 36x plus 308. So then what I'm going to do is I'm going to use the quadratic formula to solve. So x equals negative b, so negative 36, plus or minus the square root of b squared, so negative 36 squared, minus 4 times our a, which is 1, times our c, which is 308. All of that is over 2 times our a, which is 1. So this ends up being 36 plus or minus the square root of something. Let's find out what that something is. So we have negative 36 getting squared minus 4 times 1 times 308. So it ends up being 64 over 2 times 1, which is 2. And I'm kind of running out of space, so I'm just going to go up here. So I have 36 plus or minus. The square root of 64 is actually 8, and that's being divided by 2. So I have two possibilities, 36 plus 8 divided by 2, or 36 minus 8 divided by 2. Okay. 36 plus 8, and then divide by 2 gives me 22. And then 36 minus 8 divided by 2 gives me 14. So these are my possibilities for x. X could equal 22, or x could equal 14. Now, we need to talk about which one's reasonable. Look back at your picture of the volume. This side is x minus 18. If we allow x to be 14, then we would have 14 minus 18, and so this side would become negative 4. we can't have a -4 for the length or the width of our box. So this answer doesn't make sense in the context of the problem. So that means the x has to be 22. So my answer is going to be 22 inches by 22 inches. It has to be a square, because they told us it was a square piece of sheet metal, and our measurement for one of the dimensions, x, was 22. So we have a 22-inch by 22-inch piece of sheet metal, and that'll give us this thing. And so we can actually check it and see if we're correct. If we plug 22 into this equation, let's see if we get 144. So go over here, parentheses 22 minus 18, close parentheses, parentheses 22 minus 18, close parentheses, times 9. And look, we do get 144 as the volume, which is what we were supposed to get. So we did do it correctly. So it's 22-inch by 22-inch piece of sheet metal. And that is the end for section 1.2, all about quadratic equations. Again, if you have any questions, feel free to email me.